Okay, so for today we're going to do some exercises involving derivatives, and more precisely we want to use the properties over here in the right and the formulas that are well known for the derivatives. I will maybe leave a table of derivatives somewhere. Okay, and for this first exercise we want to find the derivative of the function over here. So the derivative of f is the derivative of this thing over here. And by applying the first property, we get that this is equal to the derivative of 3x squared plus the derivative of the cosine. And going forward, we get that the derivative of 3x squared only passes to the x squared, so we can move the 3 in the front, and the derivative of the cosine of x is equal to minus sine of x. So once again, the derivative of x squared is equal to 2x, giving us 3 times 2x minus sine of x equals 6x minus sine of x. And this, if this seems really easy to you, don't worry, the exercises are getting progressively harder. So maybe you can skip ahead to the end or the middle if you want something more complicated. So this being the first example, let's pass on to the next one. So we want to calculate the derivative of the root 3 of x plus twice the logarithm in base 2 of x. So once again, using the first formula, we only have to compute the derivative of each term. So the derivative of the root, the radical, and the derivative of the logarithm. But once again, this is equal to the derivative of the radical. We don't really know a closed formula for it, or at least I don't tend to memorize it, but I can always compute it if necessary. So I will just write the radical as x to the 1/3 and do the derivative using the power rule. And for the next one, the logarithm, the formula for the logarithm is just 1 over x times the natural logarithm of whatever base there is. So if we have base 2, then we get the logarithm of 2. And the first one, we would just get that it's 1 over 3, once again, using the power rule, times x to the minus 2/3. So the exponent that we have right here gets divided by 1. And this we have to add to 1 over x ln of 2, and using this we get 1 over 3x to the 2/3 plus 1 over x times the natural log of 2. And there are maybe some ways to simplify this even further, but I want to do more exercises with derivatives, and I want to accentuate the notions and the properties of derivatives rather than using simplifications. So for a third exercise, I will use the product rule. So say we have something like f of x is equal to x squared times e to the x. And let's see what the derivative is. So I will calculate the derivative of the first term times the second one. And now I want to add, so let's see how the formula was. So I did f prime times g, and now I want to add f times g prime. So the first one doesn't do any derivation, so we have x squared. And now we want to derive e to the x. And let's see what we get. So this is equal to x squared derived is 2x. We have to multiply this by e to the x. And the other term evaluates as just x squared times e to the x, because once again, e to the x derived, so using the derivative for e to the x gives us exactly the same thing. Okay, and we get this function over here. And let's see an example with the quotient rule. So say the f of x is equal to x plus 1 over x squared plus 1. This is well defined. Notice that denominator doesn't cancel, so x squared plus 1 is always different from 0. And let us calculate the derivative, and we get the first one we have to derive the first one and leave the second one as is, and then do nothing to the first one and derive the second term. So x squared plus 1. And everything here, it has to be divided by the square of the denominator. So this is the g, and here is the g squared. Okay, so let's see what we get. By distributing the derivation sign to both things over here, we only get that the derivative of x plus 1 is equal to 1. And so on, we multiply it first by x squared plus 1, of course, and over here we get x plus 1, and the derivative of this thing over here is just 2x, because the constant term, the 1 over there, cancels out, and the derivative of x squared is 2x. Okay, let's divide it by x squared plus 1, everything squared, and see what we get. So I have x squared plus 1 minus 2x squared minus 2x. I distributed the 2x over the x plus 1 in the parentheses. So subtracting an x squared, oh, I forgot to place the denominator, sorry. So therefore subtracting an x squared gives us minus x squared minus 2x plus 1 over x squared plus 1 squared. And this is the derivative of f. And now for the last example, I want to do one using the quotient rule. So say f of x is equal to, I don't know, 2x squared plus 1, but everything is to the 6th power. So say it is something like this. F prime of x is equal to, and we have to notice, I will rewrite the formula over here. So we have something like this. We have a composition of functions, and when everything is derived, we get f prime of u of x, and we also have to multiply it by the derivative of u of x. And in our case, we can look at it from the exterior to the interior. That's how I choose to do it. And we can denote by u of x exactly this quantity over here. So I will just use the derivation rule as the power rule first, because we have something. We have u of x to the 6th power that has to be differentiated. So I will just write 6 times u of x to the 5th power, and we have to multiply it by the derivative of u of x. And once again, if u of x is equal to 2x squared plus 1, then its derivative is, can you take a guess? Well, of course, it is equal to 4x. And thus, in the end, gives us 6 times 2x squared plus 1 to the 5th power times 4x. And we can actually multiply the 6 and the 4x to get the final result, which is 24x times 2x squared plus 1. And I want to take one last example using the composite functions. So we actually have to use the product rule as well as the 5th rule, the one for composite functions. So let's go ahead. We have to use the product rule first, and we get that it is x prime times e to the x squared plus x times e to the x squared differentiated. And the derivative of x is precisely equal to 1, and we have to work a bit for the derivative of e to the x squared, which we don't know. So I will just write the first term. I will omit the 1 because it doesn't do anything. And we add x times, and I will use this time the function u of x is equal to x squared, and differentiating u to the e to some power will give us exactly e to that power, so e to the x squared. But we also have to multiply it by the derivative of that u of x, which in this case is equal to 2x. Or say, I will simply write an extra step so that you can follow. So we get e to the x squared plus x times e to the x squared times 2x, and thus giving us e to the x squared. We can group the x and the 2x and get 2x squared times e to the x squared. And to make it look nicer, we can factor out an e to the x squared, and this multiplies 1 plus 2x squared, and this is the final result. So thank you.